We are live, Anuji?
Yes, ma'am, we are live, ma'am.
Okay. So let me also just start recording this. Let me start by sharing the screen. So a very good evening, everyone. Welcome to the YOSI Journal Club September session. And the whole concept of the YOSI Journal Club began with the, the age-old saying, publish or perish. And so this is the team YOSI, the YOSI Governing Council. We have Dr. Sonal Kalia as the president, Dr. Digvijay Singh sir as the immediate past president, Dr. Divakar Mishra, the immediate past secretary and the vice president, Dr. Karan Bhatia, the secretary, Dr. Avnish Upadhyay as the treasurer, and Dr. Nilesh Kumar as the joint secretary. So, and this is our pan-India executive team, I being one of them, and Dr. Anujit, who's also on the YOSI JC team, being one of them. It's a very dynamic team of the YOSI GC and the executive team, which is working very hard together as a team to, get YOSI to where it is as of now. So, this is the team for you. So the whole concept of the YOSI Journal Club, how it began, So what we realize that young ophthalmologists in different stages of their career, right from a postgraduate year one to a young ophthalmologist in practice, have different questions in mind with respect to a journal article. It could be for a postgraduate resident, it could be with respect to a thesis or kind of studies they need to do. For a young ophthalmologist, how can you evolve your clinical practice by using the various clinical research articles? So also to learn to interpret the journal article, read between the lines and help understand the biostatistics, we came out with the concept of the YOSI Journal Club. So the Journal Club is basically assessing the research literature. So it's definition of the problem, specification of research question, definition of the variable, selection of subjects, selection of appropriate research design, analysis of the data, interpretation of results, and dissection of the article in the MARI format. So the it's a beautiful format of the YOSI Journal Club, which was actually, the brainchild being Dr. Sonal Kalia, who is the YOSI president. So it's a concept wherein a presenter who's generally a young ophthalmologist, a postgraduate student, or a fellow presents a journal article of a specific specialty under the guidance of a monthly mentor. We have moderators from the Journal Club team. Then we have a research expert who's good with biostatistics and clinical experts in the field. So this is the concept that we've been having monthly webinars, and this is how the whole pattern has been going on. So MARI format, we've been having monthly webinars. This is the step-by-step approach to reading the medical evidence. So this is the team YOSI Journal Club. We have a very dynamic team, myself being there, Dr. Anujit, who's been the backbone of the Journal Club. We've been having regular monthly webinars thanks to his wonderful coordination. Dr. Rohit Modi, who's been extremely helpful with the statistical analysis, Dr. Bharat Gurnani. So this is the Journal Club team. So in case you wish to present or be a panelist or have any suggestions, you can email your interest or present your suggestions to the following email ID. So we've had a very successful run. We started in 2021. We had different specialties. We had 4 Journal Club sessions there. Then in 2022, we continued the successful run. Again, as you can see, various articles being discussed, various specialties, retina, pediatric ophthalmology, 22 continuing. Then we started again in 2023. We've had all specialties discussed: glaucoma, retina, ocular cataract surgery, uveitis. The last one was being oculoplasty. So, we after having so many journal article discussion, what we realize that the biostatistics, when you hear the word, this is how you feel. A lot of question marks come for us, including me. So we thought, why not, also address this issue of biostatistics for a young ophthalmologist. This is often a topic which is ignored during residency. So, with this, we have, brought this session today, the biostatistics special session, and we'll also be having Dr. Vanati join us, who's the IGO editor, and we'll be having the IGO YOSI live wire with her, and the details will be shared soon on what will happen with in that. So we have some very interesting topics to be discussed by our own young ophthalmologists. As we go along, we will further elaborate on that. So it's my pleasure and honor to have as chief guest and panelist, Dr. M. Vanity ma'am. Ma'am is the professor of ophthalmology, cornea, refractive and refractive services at RP Center, AIMS, New Delhi. She's also the current editor of Indian Journal of Ophthalmology 2023 to 2026. She has been a member of several national and international academies. She's been a reviewer of several index international journals. She's more than 150 international index publications to her credit. She's the chief author of landmark review articles in surgery of ophthalmology, surgical techniques. Ma'am needs no introduction. We're so honored to have ma'am with us. Thank you so much, ma'am, for taking time to join with us today. And
thank you, Dr. Nupur, and wish you a wonderful webinar. And I'm sure I have lots to learn from listening to the young minds here. Thank you for having me with you.
Thank you, ma'am, for agreeing to join us. It's a big source of encouragement to all of us to have you here. Thank you, ma'am. And moving further, we have Dr. R.M. Pandey, sir. Sir may not be able to join today, but sir is a PhD from IIT Mumbai and postdoc in biostatistics and epidemiology from University of North Carolina, Chapel Hill, USA. He's a former professor and head department of biostatistics, AIMS, Delhi. He has more than 30 years of teaching and research experience and 600 plus research publications. He's a fellow of Indian Society of Medical Statistics, fellow of the Royal Statistical Society of UK, and fellow of National Academy of Medical Science. Yeah, and currently, Mr. A.S. Pendle, National Chair of MR. And yes, this is Dr. Sir. The next is our own very dynamic young ophthalmologist, Dr. Zain Khatib. He's a consultant ophthalmologist at Khatib Eye Clinic and Perfect Vision Laser Center, Mumbai. He's an expert in cataract surgery, LASIK, refractive surgery, and glaucoma. He's done his MBBS from the prestigious St. G.S. Medical College in KM Hospital, Mumbai. He's done his MS ophthalmology from the Karnataka Institute of Medical Sciences, Hubli, and he has a lot of other degrees to his credit. He's fellowship trained in phaco refractive and advanced anterior segment surgery from Lakshmi Eye Institute, Mumbai, and Modern Eye Center, Salt Lake City, USA. He's a recipient of a number of international awards and recipient of the AIS International Ophthalmic Hero Awards 2 years in a row. He was also recipient of T.P. Lahane Award for Best Paper in BOA Focus 2 years in a row. And he was also recipient of YKC Pandit Award for Best Paper at Moscow 2020. So welcome, Dr. Zain, and thank you for agreeing to be on board and being a panelist for this session. And this is me, one of your moderators. I am currently working as a consultant anterior segment and oculoplasty at Eye Care Eye Hospital and PG Institute, Noida. I am one of the YOSI executive members, and I also lead the YOSI Journal Club and the YOSI Socio-Cultural team. So then the next moderator is Dr. Anujit Paul, very dynamic. He's currently a Vitreoretina Fellow at BBI Foundation, Kolkata. He's a recipient of IGO Platinum Award in 2021. He was also the recipient of TNOA Gold Medal in 2021. He has 23 PubMed Index publications in national and international journals. He has presented papers in state, national, and international forums, and he's very passionate about ophthalmic education and research. So with this, with the introductions, let's not further waste time, and I would like to introduce our first speaker, Dr. Rohit Modi, a very good friend. Dr. Rohit Modi is a fellowship-trained vitreoretina and uveitis specialist and special interest in biostatistics. He's a director of Centra Clinic and Hospital, Mumbai. So Dr. Rohit will be speaking on a very important topic of biostatistics, which is how to calculate the sample size. So over to you, Dr. Rohit.
Yeah, hi. Thanks, Nupur, and thanks, Anujit, for this wonderful opportunity. And ma'am, Vanity ma'am, looking forward to learn from you. A lot of this presentation has been taken by the articles, which I've read on statistics from IJO. So would highly recommend everyone who's watching, especially the young ophthalmologists, to pick up those simple lucid articles which are there in IGO. Yeah. Is my screen visible?
Yes, sir. Yes.
Yeah. So one of the key things when we are planning to, conduct a study or even understand a research paper is to understand what is the sample size calculation. A lot of papers which I come across, there is ambiguity in sample size calculation. And many a times this ambiguity, if we can clear in our head, it will help us in further understanding of the paper. Now, why it is required? We obviously can't test the entire population. You have seen the televisions, the newsroom guys coming up with the post poll analysis or predictions or exit polls. They are just not covering the entire population. They are not redoing the entire polling. They are just, taking a sample size, a few people, asking them whom did they vote for. Now, basically, if we are able to conduct a study in a smaller size and then extrapolate, it helps us in better planning, saving us the resources. And many a times it is not even feasible to do a large study. And it basically enables the researchers to draw robust conclusions and also permits the generalization of results. Now, there are certain elements in sample size calculation. These are pure basics. If one can understand these, then sample size calculation becomes quite easy. The first is understanding what is the type of data and distribution. For the simplified way, there are two types of data we are looking at. Qualitative, it means that it is a categorical data, something like, stage 1, 2, 3, 4. Or it is quantitative. Quantitative would mean, you can actually measure the quantity, something like intraocular pressure or blood pressure of a person or weight, height in centimeters, something on those lines. Now, the size of the effect that is clinically worthwhile to detect. I believe this is one of the most important and the cornerstones of understanding sample size calculation. Now, there is something known as which is statistically significant, the difference between the two groups, and something which is clinically significant. Now, let me give you an example. Let's say we are comparing two drugs for glaucoma. Why I'm choosing glaucoma? Because that is easily understandable by each one of us. Now a rep comes with a newer drug and he says, doc, look at this new drug. It's a blockbuster drug. We found statistically significant difference. Look at the research paper. But when we see clinically, the additional decrease in IOP is somewhere around 0.2 millimeters of mercury or 0.1 millimeters of mercury. But the cost difference is going to be 3x or 4x because it's a newer drug. So whether it is going to be clinically relevant in my patient is the question. So a small but consistent effect, if you have a large enough size, it may be picked up if the sample size is large. So everything which is statistically significant need not be clinically be significant. I believe my other co-speaker would speak about p-value versus confidence interval, where he will elaborate more on this topic. Now, let's say here is the example of an antihypertensive drug, which lowered the IOP 1 millimeter more than the conventional treatment. Results were statistically significant because the sample size was large enough. I'll show in my further slides how we can play around with numbers. But it doesn't mean that this drug is going to be clinically be relevant. Now, let's say drug, I've already discussed this example. Yeah. Now, clinical meaningful difference, which will make a physician change his practice pattern, is going to be the key. And that is what we are looking at. Now, this meaningful difference is something which one has to decide before starting the study. Now, the other aspect which is important is the probability of falsely rejecting a true null hypothesis or the alpha error. Now, this is a very dangerous, that there was no clinical difference between the two groups, but a difference was found. And this is known as a false positive error. Though we have got a positive finding, but it is false. Because what will happen is, if we find a difference in the two groups where there is no difference, we can start implementing the new therapy in practice, which effectively doesn't have much role to play. Now, typically, this is known as p-value, and it is conventionally set at 5%. But mind you guys, p-value is not something which God has given or it has come from, Gita, Quran or Bible. It is what we have decided. And it was a simple Fisher's hypothesis that if you toss a coin 20 times and if 19 times head is coming and one time tail is coming, then that coin is special. It is unlikely that it is going to happen by chance. There is something more than chance. But just as a thought process, let's say you toss a coin 20 times and let's say you get heads 18 times and tails 2 times. Wouldn't you start thinking this coin is special? But there the p-value is going to be 0.1, not 0.05. So p-value is something which we have to decide before we start with our sample size calculation. Now, let's say we are treating, we are evaluating a treatment for retinitis pigmentosa, where the p-value at 20% is also acceptable because there is hardly any treatment which is available. Whereas if we are treating a life-threatening situation where we want more accuracy and more accurate data, we can keep the p-value as 1% also. Now, false negative error, it is the probability of not finding a difference when an actual difference exists. Now, what does it mean? That drug B is better than drug A, but due to a probability chance, we were not able to pick it up. Now, this is conventionally set at 10 or 20%, and this is known as the power of the study. Now, this thing also depends upon what we decide before the start of the study, because keeping it lower would mean a greater sample size. I'll show it in the online calculator, how the sample size varies when we decide the false negative error. And another thing important is the standard deviation of the population. This is the variability or the spread associated with the quantitative data. I'll come to that in my further slides. Now, let's look at some of the examples which are available. Now, if we have two independent groups, now this is a sample size calculator which is available online, and it has just very simple options which are available. And if you are thorough with your basics in terms of what kind of data you're looking at and what kind of outcome measures you're looking at, sample size calculation becomes absolutely simple. Now, typically I will start with drug A versus drug B in evaluation of glaucoma, and we are going to have a set of patients receiving drug A treatment, and we are going to have another set of patients receiving drug B treatment. So we have here two independent study groups. If we are just studying one drug versus the population mean, then we can say one study group versus population. I'll come to that later. Now, the primary endpoint is going to be continuous in terms of IOP measurement. What was the IOP lowering what we got? Now, since drug A is a proven drug, let's say we are talking about a beta blocker. Now, this is just a hypothetical numbers which I'm going to put. And let's say a beta blocker like timolol maleate at an average reduces pressures by 6 and has a standard deviation of 2. Now, to get a clinically meaningful difference, I would want the newer drug to lower the IOP at an average by 8. Now, I can either choose the mean which I'm looking at in group 2 or the percentage increase. So I can say the percentage decrease in IOP, I want at least the difference between the two groups as 20%. So I want a 20% more efficacious drug. Now here the p-value, that is the alpha, I'm going to keep at 0.05 and power I'm going to keep as 80%. Anujit, is my slide visible, the online calculator?
Yes, sir. Yes, sir. And your real-time edits are also visible.
Okay, great. Thank you. Now I just press the calculate button and I get a sample size of 63, and here I can see the 20% decrease the calculator has calculated to be 5. Now let's play around with the alpha, that is a p-value. I want it to be even more accurate. I don't want to leave it to chance. I want to be 99% sure that there is a difference which is existing between the groups. Now, what do you see? The sample size has increased from 126, it has increased to 186. When I am decreasing the p-value. Now, I gave you an example of retinitis pigmentosa. So I make it 0.2 instead of 0.05. And when I calculate, you can see from 126, when there was a convention value of 0.05, I've increased the p-value to 0.2. From 126, it has come to 72. And if I define the p-value in my methodology, in my study as 0.2, I can actually say in the conclusions that the p-value was significant. So every author needs to define the p-value in the methodology. Now, power. Let's say I increase the power to 90% and I keep the p-value to the conventional thing of 0.05, and then I calculate. So from 126, it has increased to 168 because I've increased the power of study. Now, when the sample size increases, the duration of enrollment may increase, the resources which are required increases, and for certain diseases, it may not be possible to increase the sample size. So sometimes, even if we get a p-value of 0.06 or 0.07, though statistically not significant, it may have a lot of clinical significance. Now let's compare one study group versus population. Here again, now the population mean for IOP in one of the papers which I had read was 14.7 plus or minus, that's a standard deviation of 2.8. Now for the study group, since I want it to decrease, let me say the decrease is by 20%. And I calculate the sample size and I keep it at the conventional levels of 0.05 and power at 80%. And here I can get the sample size required is 7. And this is going to be just 7 patients being using those drops. And if I get an average decrease of 20%, I can consider it to be clinically be significant. So this way, you can actually play around with the numbers. Now, dichomatous would mean it's a qualitative data. And let's say we can see the incidence of a high IOP in a population in, let's say, 10%. Or we can see that primary open angle glaucoma, if left untreated, would lead to complete loss of vision in 10 years. So 30% of the population would go for complete blindness. Whereas in the study group, if the drug is used, I would want a 50% decrease. And then I set to calculate. And I get the sample size as 64 because I'm just comparing one drug versus population. Now, if I have got 2 independent groups, means I'm calculating 2 groups. I can write what is the increase in survival or decrease in the mortality or the event which is going to occur or the incidence. Let's say the adverse effects we are comparing between 2 groups. So the first group, the adverse effects is 20%. The second group, I wanted 30%. And then I can just press on calculation. And here I get my number as 586. So sample size calculation is pretty simple and there are very good tools available. There is a beautiful article of IJO, which I have found pretty useful. It is by Dr. Nitya Gogte on sample size calculation. Thank you. Thank you for the opportunity.
Thank you so much, sir. I think we can move ahead and Prasanna sir, could you please share your screen?
So let me just introduce
is going-
Dr. Prasanna, let me just introduce you before you move on to your presentation. Yeah.
Dr. Mithun is going next, or you want me to go, ma'am?
We can have Dr. You as next, if you're okay with it.
Yeah, I'm ready with it.
So introducing Dr. Prasanna Venkatesh Ramesh. So he is currently the research director glaucoma head at Mahatma Eye Hospital, Trichy, India. He has published 147 articles in various PubMed index journals with 247 citations and H index score of 7. He has delivered 366 scientific presentations at various international and national conferences. He's the editorial board member, General Ophthalmology and the video section of IGO 2023-2024. He's also the associate editor and the editorial board member for TNOA, Journal of Ophthalmology, Sciences and Research 2022 to 2023. He is the DNB FAT examiner, DNB coordinator of MEHPL Institute of Thesis Guide. He has trained 6 postgraduates so far. He's also the management committee member of Tamil Nadu Ophthalmic Association. He's conducted various instruction courses as chief instructor in ASCRS, APO, AIS, GSI, and TNOA. He has been the recipient of awards in ASCRS, WGC, APAO, FC, AIS, GSI, TNOA, LVPI, DOS, YOSI, and Arvind Eye Care System conferences. He has delivered 1 oration and performed 1 live surgery. His area of research are glaucoma surgery, MIGS, moving images, YouTube, 4D diagnostic, augmented reality, artificial intelligence, and academic filmmaking. So that's Dr. Prasanna for you. So we often have a joke, going around with the amount of awards that he keeps winning. We feel that he should have a separate mansion to accommodate them. So over to you, Dr. Prasanna, to give your talk on p-value and confidence interval.
Thank you. Thank you, ma'am. Is my slides visible, ma'am?
Yes, sir. Yes.
Okay. Thank you for the kind introduction, Nupur ma'am, and Anujit also for this wonderful invitation. So I would like to thank my editors under whom I have published, Dr. Santosh sir, Dr. Shamila ma'am, Dr. Jayantan sir, as well as to my dear friend Anujit, to Dr. Nupur, and the whole team of Your Journal Club. And also thanks to the recent editor, Dr. Vanati ma'am. So thank you all, and let us go to the topic per se. I'll also have few practical tips like how Rohit sir was telling. So it's more of basics. It is just one way. It is not the way, but I felt it will be more basic, and for the neophytes and novice people who are seeing this webinar, it will really help them. So statistics is something that it is involving a lot of data. We all know about it. So I've tried to keep the discussion to some of the publications of mine, the original articles that I have published in the PubMed Index journals. So usually we start with descriptive statistics, right? So meaning that descriptive meaning, like as you can see in this, this is more like a percentage. Like we start with age, sex, and this is a handedness study. Left-handedness versus right-handedness. We wanted to compare the dexterity of the ophthalmologist with standard procedures. So we start with simple numbers, meaning frequency distribution, starting from a pie chart. So then we go into frequency count. So we start with a pie chart or a frequency distribution with percentages, and then you can see the count, right? So we can see that certain characters are more in number, we'll have 2 in number or 3 in number. So each terminology is different, but I, for one, I think I relate myself with a lot of pictures. In a statistics, when you have a lot of pictures, right, you will understand the concepts much better, or with more examples, you will get the concept much better. And then you have the inferential statistics. In inferential statistics, you can see, you will always have the relationship between observation and how do you relate it with hypothesis. So again, to go back, so you have an observation and then you have an hypothesis. So you can see that you will have an observation. So in COVID time, what we felt was, especially in the first lockdown, we were not able to use the fundus to actually 90D to use, because we were feeling we were touching the patient's mask. So in our center, we used the non-mydriatic fundus image, and that was our observation to measure the fundus, and we wanted to evaluate the image quality. Our hypothesis being that in this particular camera, the image qualities are much better, and what pupil size or what the pupil will have an effect on the image quality of it. So that's a study that we did, and you can see that how our observation is going to go hand in hand with the hypothesis. We feel a particular hypothesis, Whether it is right or wrong, I think that observation at the end will be statistically significant or not. So that is inferential statistics for you, my dear friends. And p-value. I think to start on p-value, it originated from the 20th century. I think we should never forget where we all started, because history is something that is very, very important. The inception of p-value was introduced in 1900 by Carl Pearson. But however, Sir Ronald A. Fisher was the one in 1925 who first gave the different permutations and combinations to calculate the p-value in a wide variety of situations, because we will be having a lot of variety of situations. Pearson just gave it in a chi-square test, but it was the father of modern statistics, Sir Ronald. He gave this from Great Britain in different circumstances. If you use a chi-square test, how you do it? If you use a Kruskal-Wallis test, how you do it? And then this is something that is very important today, my dear friends, where p-value and significant tests, when properly applied and interpreted, increase the rigor of conclusions drawn from the data. It doesn't mean if a p-value is significant, it is clinically significant. It just increases the rigor of conclusions drawn from the data. So that is something that we need to keep in mind. Just because a p-value is significant, we cannot say it is statistically or clinically significance is totally a different thing. So this has been associated by the American Statistical Association, and this statement has been come because of the lot of misuse of p-values. Right. So let us go into some basic concepts. So what is a p-value? Or you can see that probability distribution is something that we need to understand when we go for a p-value. And predominantly, as you can see here, me pointing out in my mouse, we'll have an unknown probability distribution. That is what we commonly deal when we see in real-time scenarios. So what is a known probability distribution? So for example, you take a dice and you throw the dice. You will have 1 out of 6 probabilities that you may get a 1, or you may get a 2, or you may get a 3, 4, or 5. So that is probability distribution. So the chance that you may get 1 is 1 out of 6, or the chance that you may get 2 is also 1 out of 6. It's 1 out of 6 that you will get. But in reality, I think I'm just pushing you one step further. 2 dices. Take for 2 dices, for example, and what are the different probabilities that you will be getting different numbers. For example, you are adding. Take, for example, you are getting, I'll just take you to the next level. So in 1 dice, you have 1, 2, 3, 4, 5, and 6. And then you are having 2 dices. In a single dice, it's very easy. It's 1 out of 6, the number of affair and the total number of affairs. So the number of affair, you take 1 and you have total of 6. So it's 1 by 6. It's pretty easy. And you can see the green highlighted box here. 1 divided by 6, it is 0.1. So it's very simple. But when you take 2 dices, mostly what happens is you get the 7 is the most favorite outcome. Meaning, if you get 1 in 1 dice and 6 in the other, 1 plus 6 is 7. And let us see the different permutations and combinations. So this is a graph that I made today. You can see how you get 7 as the most common. You can see that in 1 days you get 2, in the other days you get 5, or in the first days you get 5, and in the second days you get 2. And in similar ways, you have 3 and 4, and you can vice versa it, and you have 1 and 6, and again you can vice versa it. So when you have 2 dices, right? I'm just going back to the probability here. When you have 2 dices, the chances are 36. The denominator will be 6 into 6. You have 36 chances. And predominantly when you take, for example, when you add dice 1 with dice 2, when you roll it, predominantly you will end up getting 7. If you roll today 2 dices, you're playing a game, you're taking a gamble, you're going for a casino or something like that. If you have 2 dices in your hand, you should call out 7, because the 7 falling out is the most highest probability. You can see that 7 coming out is 6 times out of 36, and it is 16.7, as you can see in the mouse that I'm just encircling here. So I'm just going back again, and you can see this particular chart on the left. So how p-value is related is what I'm going to bring you slowly in. So you have totally 12 permutations and combinations. In that, if you see the additive of 7, it can come 6 out of 36 times. So that is the probability distribution of 2 dices. So these are all real-time scenarios that we tend to do. And this is in a study, what happens is we have an observed data, which is all having different random variables, right? In dices, in a single dice, we had 6 variables. Then we went for 2 dices, we had different variables there. But in a study, we'll be having more random variables. So more the random variables in that observed data, you'll have unknown probability distribution. So that is where we start hypothesizing. So what is the chance of this particular dice or we getting 7 for different ways, right? How 7 came 6 out of 36 times. So that's how we start hypothesizing. That is what we call as statistical hypothesis. So if we state one hypothesis and aim for the statistical test to see whether the hypothesis is tenable, but we are not investigating the other hypothesis, then that is called a null hypothesis. So basically, we are just giving a type of statistical test. We are hypothesizing only for one particular parameter, and that is what we say it as an hypothesis. So a null hypothesis. A null hypothesis is a type of statistical hypothesis that proves that no statistical significance exists in a set of given observations. So let us just dissect what it is. It's a very simple thing. Have it in a very pictorial way. Don't read a lot of theory. I feel I'm going to just dissect it in an image point of view. So in a null hypothesis, the p-value will be greater than the level of significance. We always take a p-value of 0.05 for practical purposes. And we always, if it is significant, that means the alternative hypothesis is true. That means the p-value is less than 0.05. That means the p-value is smaller than the level of significance. If otherwise, if the p-value is more, that means the null hypothesis is true and the study is not statistically significant. So again, this is another picture I just wanted to show you, my dear friends. Like you can see that sunlight or light color has no effect on plant growth. That means null hypothesis is true. Whereas the alternate hypothesis, light color affects plant growth. So that means light or sunlight, no, they really have an impact on the plant growth. So that is all about p-value. And the probability of getting an outcome as extreme, that is something which is very, very important. See, for example, the p-value can be in between 0 and between 1. As close as it is to 0, that means 0.05, 0.005, 0.001, as close as it is to 0, the observed difference is unlikely due to chance. So that means it is not due to chance, the test is much significant. So the chance is as minimal as possible. If the p-value is more close to 1, then there is no real difference between the two groups that we are actually studying, which we all are accustomed to, and we are doing it in our real today circumstances. Again, this is one of my publications in Indian Journal of Ophthalmology, which won the IGO of Certificate of Merit Award last year. So we studied between the AGM compliance and the primary glaucoma patients who are literate. A lot of studies were focusing on illiterate patients. We focused on literate patients in an urban tertiary center. If you see the p-value, so most of the p-value you can see here, they were all close to, only one was close to 0, and predominantly the other factors, AGM compliance versus expenditure, duration of usage, number of anti-glaucoma medications, awareness of it, or be it for purchase of bottle history, stocking history, they were all close to 1. They were not close to 0. That means it was not significant. So you need to know how p-value works, and we publish the negative results as and when they are. And that really made a difference because AGM compliance did not have any particular role to do with the stocking behavior or the purchase behavior or the stocking as well as the number of bottles that they were buying. So you need to keep in mind how the p-value, when it is more close to 0, right, it is more statistically significant, and the alternative hypothesis is much good if it is more close to 0. The null hypothesis is now discarded. If it is not closer to 0, then the null hypothesis, which is basically the opposite, that is more part of it. If you get a statistically significant p-value, you can reject the null hypothesis. So these are things that we already seen, and keep pictorial representation so that you will understand rather than mugging up with more numbers. So keep tick marks or p-value less than 0.05 means alternative hypothesis is good. Again, as close as it is 0, be it 0.05, 0.01, 0.001, they are all meaning that the alternative hypothesis is much good, a thumbs up sign. Again, this is another study that I already showed you. Look at the p-value here, my dear friends. A p-value of less than 0.01 by 2 asterisks that I have shown here. P-value of less than 0.05 is a single asterisk that I have shown here. This is a very practical study. Like you can see the p-value which is more significant, right? It is more related to how much of you do rhexis in both hands. You can see that most of the surgeons, no, they were not doing rhexis with both hands. There was a huge difference in those groups. And you can see that also you can see foreign body removal, foot pedal, irrigation aspiration, bimanual, they were all changing it and they were using it in both the hands. And again, you can see that we published a lot of mixed-handedness studies in different procedures, how they were statistically different, significant. So you get to understand which group are more closer to the zero. So that is what we are trying to tell. The more closer they are to the zero, the more you are telling that, yes, there is a good significance. So that is the take home that you need to keep in mind when you keep p-value. And this is a simple study, be it gonioscopy, 90D, 20D, IDO, direct ophthalmoscope, laser procedures. You can see the 2 asterisks. 2 asterisk means they're more closer to zero. The single asterisk means they are just slightly away from zero. I think you can go back and read this. And what if you don't get a statistically significant value? Don't need to worry. Just because it's not significant, it doesn't mean the study is not clinically significant. You need to refine your study. You need to hypothesize this much better. Need to do further studies. So that's what you need to take into consideration. I've had studies which were not statistically significant, where we try to compare the association between CCT and ocular dominance. Then we had to reassess ourselves, go back to the drawing board, and then we had to refine ourselves. So you will not always have studies, which is in the AGM complaint study, you can see that the patient's behavior was different. Different patients had different behavior. That's why they were not statistically significant. Right. Moving on to the next parameter for the next few slides on confidence interval. So, ma'am, you can tell me when my time's up. I'm just winding up with confidence interval.
Yeah, if you can wrap it up a little.
Yeah, within 1 or 2 minutes. Yeah. So with confidence interval, you can see it is just an additive part of p-value, which brings in certain biases. Like, I'll just push more forward. A p-value gives you the strength of the result. A confidence interval will give the precision of the result, how precise the result is. So the bottom line is the confidence interval will remove the uncertainty, will remove the chance, will tell you, like, for example, there are certain formulas. I'll skip the theory. In the confidence interval, you can see how many times you will get a reproducible estimate within that particular area as seen in the red arrows. I'll skip the theory for want of time. There is proportions, population estimates, and a lot of other things. This is one particular study that I wanted to highlight you. It's a Britain and a UK. Both are watching the TV for 35 hours a week. You can see that both are watching the TV for 35 hours, but you can see that the spread in USA people is much wider. Rather, the UK people is much wider compared to the UK people. Predominantly in intraocular pressure studies, you need to keep this in mind where we are taking the curve, especially for studying. There is a picture which is classically published on this. So this is very, very important when taking the confidence interval. I think for want of time, I'll skip the theoretical slides. We'll have more of a practical discussion. So when you have this difference confidence interval, that itself influences your study. And when you can see that for USA people who had a more taller bell curve and the UK people who had a more broader bell curve, you can see the how confidence interval is more of plus or minus 0.98 for the US people who are watching TV. And for the UK people, it was 1.96. So the confidence interval plays a huge amount of role in how you not only interpret the result, but also how much of chance and uncertainty is actually removed. I think it's a different class of its own. And there are many different studies that we have done. You can see that the confidence interval has to elapse the points in a much precise way between the plus or minus 2 standard deviations or 1 standard deviation, depending on what you are taking. And these are some of my studies where I've used confidence interval to really evaluate not just the p-value significance, but the confidence interval is the one that will help you to understand things better. So a large sample size will always give you a narrow confidence interval, which is always better. So that's why my previous speaker, he was pointing out about the ambiguity in the sample size, which is very important. And you need to calculate your sample sizes. And a good p-value doesn't always say that the result is good. A confidence interval, which is more narrow. So always when you read a paper, p-value, make sure you construct your confidence interval, which is more narrow, as the US people you just saw here. And I think that is all the take home I feel you should all take home at this particular thing. I think thank you, Anujit. We'll avoid all the theory for this opportunity. I hope at the end you understood what is p-value. It has to be more close to zero, and your confidence interval should be more peaker, more narrow. That you'll get it only when you have a solid p-value, which is 0.05 or a 0.025, which is much more lesser, as well as a confidence interval which should be more taller, which helps you in interpreting the results much better, and the study will give you much better. And this is my publication data. I think the more we publish, the more you'll get wiser with all this. I think, thank you, Anujit. Thank you for the Yo team. Thank you for this opportunity.
Thank you so much, sir. Very, very lucidly explained for the audience. I'd like to just ask Zain sir for his comments on the interval, if there's anything you would like to add in.
Thanks, first of all, Anujit and Nupur for inviting me. See, me being a private practitioner, basically, would like to give more of a practical kind of approach to this. So, Prasanna very, lucidly explained everything about P interval, and so did Dr. Rohit. As young researchers, anytime you come up with some innovation or any kind of thing, you should always think about uh, publishing it. And if you want to publish it, it can be as small as, a small device you would have made. You need to understand whether it's, clinically making a difference or no. And for that to understand these statistics is really important. To understand p-value is important. To understand sample size. So if you have probably done it on 30 patients, for example, if you tested on 30 patients and you want to present it or publish it, you collect your data and you send it. But what Dr. Rohit explained, the sample size calculation is important, because if someone is going to ask you that why have you taken 30 eyes, you need to be able to, even if you hadn't done it at that time, you need to at least use the calculator which he showed is freely available online, and at least come to a number which is close to that. Many times you're reading an article or you get questioned by a reviewer. So you need to, so that sample size part is really important. I think measures of central tendency is left, and that is something which Dr. Mithun will be covering. But yeah, that's what I wanted to add.
Thank you, sir. Yes, ma'am. Ma'am, you're muted.
Yeah, I just add on to that. Yeah. Something which we have to understand when we are doing research is you have to first have your study design. So something what Dr. Zain just said is, if you're doing a retrospective analysis of your study, the sample size is going to be different. If you're doing a prospective analysis, the sample size is going to be different. So you should not mix both. That is something which is very basic. So when you're doing retrospective, there is always a downside to it, that your sample size is not going to be enough, because you've not done a prospective evaluation to look at your alpha error, to look at your power of study. So there are multiple factors in that. So that is something which one has to understand. Just to add on to what Dr. Zain was saying. That's all. Yeah. Thank you.
Thank you so much, ma'am. For paucity of time, I think we'll move on to the next speaker.
Yeah. So I'll just introduce our next speaker. We have Dr. Mithun Tulsidas. So he's currently working at Sankara Eye Hospital, Coimbatore. He's a committed young ophthalmologist and an independent researcher. He completed his master's degree in ophthalmology from K.S. Hegde Medical Academy, Mangalore, followed by specialty training in cataract refractive surgery in glaucoma from Center of Sight, New Delhi, and Sankara Eye Hospital, Coimbatore. He has won gold medals at the undergraduate, postgraduate, and fellowship levels. He has over 50 publications in peer-reviewed index journals to his credit. He has written 7 book chapters and presented more than 50 papers at national and international conferences in 5 years. He serves a journal referee in more than 10 reputed international journals, including the European Journal of Ophthalmology, Eye and Vision Scientific Reports, Clinical Ophthalmology from the Auckland, New Zealand, the International Ophthalmology and Journal of Ophthalmology, to name a few. He has secured several awards, including the AIS Young Researcher Award in 2021, the IGO Gold Award in 2022, Scientific Round Winner in the Science and Fun in Ophthalmology AIS 2020, Best Paper at AIS Midterm Conference in 2023, the KOS Conference 2022, DOS Conferences in 2019 and 2020, YOSI Flashnote Award 2019, First Place in the Postgraduate Quiz on Ophthalmic Surgeries 2017, Best Team in the Teachers of Tomorrow session at the KOS Conference 2016, and many more. So we are very happy to have you, Dr. Mithun Tulsidas, on board with us. And over to you for your talk on biostatistics. Yes.
Thank
you wanted
ma'am.
to share? Yeah,
Yes,
you want to, yes. I'll share your screen. You can just keep telling me when to change the slide.
Sure.
So I hope the slideshow is on.
Yes.
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 So I would like to thank YOSI and especially Dr. Nupur ma'am for giving me this opportunity, and thank you for that kind introduction, ma'am. So respected panel moderators and my dear friends, today I'll be talking about how to choose the right statistical test. And most of us might have, ma'am, same slide, yeah. Most of us might have come across the same question when we initially started our thesis or when when we are planning our first clinical study. And unfortunately, most of us then depended on statisticians for the entire statistical process. But believe me, in my personal experience, there were situations where the statistician has done wrong test and the results turned out to be inappropriate. So as an ophthalmologist, it is better to know at least the basics of biostatistics, at least which test to be applied, so that you can only guide the statistician and you can work together and the results would be more appropriate and the study will be more closer to perfection. Next slide. So I would also like to thank my mentor and researcher in biostatistics, Dr. Seth Gupta sir. Next slide. Yeah, so basically for choosing a right statistical test, we need to answer these 5 questions. So the question number 1 is basically whether you're comparing a difference or checking a relationship. So comparing a difference means you are basically seeing whether suppose there is a change in intraocular pressure before and after trabeculectomy, like you're basically comparing a difference in the mean or median, or you're checking a relationship between any 2 techniques or any 2 screening methods or something like that. Second question is the scale of the data, like Dr. Rohit sir has explained. We basically have 3 types of scaling. One is continuous scale, which is basically numerical, that is quantitative, which will be continuous as the name suggests. Second one is ordinal. Ordinal is basically a categorical data, but in a specific order. So it is just like, as I'm a glaucoma specialist, I'll be giving more examples in glaucoma. So it will be like a staging of glaucoma, like mild, moderate, severe, which will be like an ordinal scale. Then comes the nominal scaling, which is again qualitative, but it is dichotomous. So you won't be having any order, unlike the ordinal scale. So you will be having 2, just like yes or no, or maybe gender, male, female type of astigmatism. So that doesn't have an order, but 2 qualitative data. Third question is whether the data is normally distributed or not. For that, we have to check for the parametric test, whether it is a parametric data distribution or whether we can use a parametric test or a data which is not normally distributed, where we can use a non-parametric test. Fourth, we have to look at the experimental design. So that's a paired design or unpaired design or independent design. So I'll make it very simple. A paired design always means a single group of sample. Means you're working on one group and you're just checking the difference. Whereas an unpaired or independent design means there are 2 independent groups, like a treatment or control, but there are 2 groups. So paired means a single group and unpaired means 2 independent groups. Then the number of groups, that is basically the number of variables or parameters you are checking, whether it is 2 or more. So these are the 5 questions which you should answer before choosing a statistical test. Next slide. So yes. So this is like I said, you are comparing a difference. Next. So like I said, so suppose you are doing a treatment like trabeculectomy and you're just checking the intraocular pressure before and after the procedure. Or suppose we are giving an intravitreal injection and checking the central foveal thickness before and after. That is basically comparing a difference in a group of people. Next one. Or checking a relationship. So checking a relationship means basically you are just seeing whether 2 techniques or 2 methods are related or not. Next one. So it is like this. This is basically a bland Altman plot. This is one of my studies where I have compared the 3 programs, either standard, faster, and faster. So I'll be discussing that in the upcoming slides. Next slide. Now this is basically the scale of the data. So now you have a question whether you are comparing a difference or checking a relationship. Next, we have to know which type of data it is, whether it is a continuous data, ordinal data, or a nominal data. Next.
Tuesday, I'm thinking.
Yeah, so these are few examples for continuous data, that is basically a logMAR visual acuity. So in most of the studies, we can see we will write the Snellen's visual, this thing is converted to logma. So this is the basic purpose, because we convert it into a quantitative variable so that it is easy to do the statistics. For an intraocular pressure or corneal thickness, which is basically numerical and continuous. Next. Or the ordinal data. Next one. So the ordinal data is basically, like I said, anything like a grading or a staging, which is in a specific order. So like a nucleus sclerosis 1, 2, 3, or a staging of the glaucoma, which is mild, moderate, or severe. Next one. Then comes a nominal, which is a dichotomous variable, which is like a gender, male, female, or a smoker, non-smoker, or a type of astigmatism with the rule or against the rule. Next one. Now you answered 2 questions. Third comes whether the data is normally distributed or not. So basically we have to see whether the assumptions for parametric test are satisfied or not. And we have basically 2 kinds of normality tests. One is analytical and another one is graphical. So analytical, we mostly go for Kolmogorov-Smirnov test if the sample size is small, that is equal to or more than 50, or a Shapirov-Wilk test if the sample size is less than 50. Anderson-Darling is almost similar to Kolmogorov-Smirnov. The only difference is it focuses more on the tails of the proportion rather than Kolmogorov, which actually focuses on the central part of the distribution. But there is a disadvantage with the analytical test, because the analytical test is basically based on the p-value. Like Dr. Prasna sir said, if the p-value is more than 0.05, that means the assumptions for parametric test are satisfied. Whereas if it is less than 0.05, it is not satisfied. So here the p-value actually depends on the sample size. So if the sample size is very small, then the p-value is very less significant. Whereas if the sample size is very large, then sometimes the p-value is overestimated. So nowadays, it is the graphical testing for normality which is found to be more appropriate than analytical test. So which we use basically using histogram or QQ plot. Next slide. So these are a few examples, like if the assumptions for parametric test are satisfied, next, which means the data is normally distributed. Here you can see, though it is not following a Bell's curve, the points are little clustered together and there is no skewing as such. So this is basically a kind of normal data distribution. Next. This is an exact kind of a Gaussian curve, which is a bell-shaped curve. Again, this is a normal kind of data distribution. Next. Here, although it is not very symmetrical, though there is little skewing, there are no extreme outliers. Still, when we check it, we will get it as a normal kind of a data distribution. Next. Yeah, however, this has, you can see there are some extreme values like the dots here, and some of the data are missing. So this is kind of a skewed data, which is basically not a normal distribution. Next. Again, another example for not a normal distribution of data. Next. So basically, if the data distribution is normal, we use a parametric test. However, if the data is skewed, or if the sample size is very less, or if it includes extreme values or outliers, we use a non-parametric test. Next. Now comes the 4th question, whether your design is paired or unpaired. Next. Yeah, next. Yeah, so like this, like I said, it will pair means mostly we are dealing with one group of samples. So you can actually pair within the group, but actually your steady population will be one group. Next, man. However, in an unpaired, you will get 2 groups. So the 2 groups will be independent, even though you're applying the same technique or screening technique, there will be 2 independent groups. So now you can classify it whether it's a paired or unpaired. Next one. So if it is a paired continuous distribution with normal data distribution, you go for a paired t-test. And if it is more than 2 groups, you go for repeated measures in a while. Next. And if it is unpaired, but a normal distribution of continuous data, you go for unpaired t-test. If it is more than 2 groups, you go for one-way envelope. Next. Now, if it is not a normal data distribution, then you have to apply a non-parametric test for the continuous data. Well, if it is paired, then you go for a Wilcoxon sign rank or a sign test. If it is more than 2 groups, you go for a Friedman test. The same is applicable for an ordinal data with a paired distribution. Or if it is an unpaired distribution, but a continuous data with skewed distribution or an ordinal data with unpaired design, you go for a man-Whitney test. If it is more than 2 groups, you go for Kruskal-Wallis test. In a nominal data, if it is paired, you go for Magnimer test. If it is more than 2 groups, Cochrane Q test. Next, if it is unpaired, definitely you will go for a chi-square test, and chi-square test can be used for more than 2 groups also. Fisher's exact test is almost similar to chi-square test. The only difference is it sometimes when the sample size is little small, or if the expected frequency is less than 5, more than 20% of the cells, then a Fisher's exact will be a more appropriate test rather than a chi-square test. Now, when we are checking a relationship, if it is an ordinal data or a continuous data with not a normal distribution, we go for Spearman correlation. If it is a continuous data with normal distribution, we go for Pearson correlation or linear regression. And if it is more than 2 groups, we go for intra-class correlation. So this slide is basically the crux of the today's presentation. If this slide, if you guys know, then anyone can choose a statistical test. Next slide. Now this is little more specific. So if you are checking a relationship, then like I said, in continuous data, you can go for ICC if it is more than 2 groups, or even a Pearson correlation can be done if it is 2 or less than 2 groups. And this is a graphical presentation of the same. So this is basically the Bland-Altman plot, where as you can see, there are 2 lines which are basically minus or plus 1.96 standard deviation. So the basic concept is that to make it very simple, all these points should be very close to each other if there is a strong relationship. If the points are not close, if they are far away, and if it is beyond this 1.96 standard deviation, it means the relationship is not good. So here, as we found, the CETA standard and FASTER are not having very strong relationship. So these points outside the standard deviation are basically the outliers or the extreme values. Now for ordinal data, like I said in the previous slide, you can go for Spearman correlation, but if it is a very small sample size, like for example, n is less than 20, then a Kendall's test is the way to go. For a nominal data, again, you can try kappa statistic if it is less than 2 groups, if it is equal to or less than 2 groups, or a Fleiss kappa if it is more than 2 groups. And when the value is closer to 1, it means there's a strong relationship. So anything more than 0.7 is reasonably significant. Next slide. So this specific topic actually needs a different lecture, but to make it very simple, regression analysis is basically a very important in current literature, because most of the time we want to compare a dependent variable on an independent variable. So if the dependent variable can be anything, it can be either continuous, ordinal, or nominal. But if the independent variable is continuous, then you go for linear regression. Whereas if the independent variable is ordinal or nominal, then you go for logistic regression. To give a very small example, like suppose if you want to compare alcohol drinking and cigarette smoking and the effect on intraocular pressure, then intraocular pressure is a continuous variable. So alcohol drinking and cigarette smoking are not continuous. Still, you can go for a linear regression. But if you want to compare it with glaucoma, glaucoma is not a continuous variable. It is something like a nominal variable. Then you have to go for logistic regression. Next slide. So I will be winding up in 2 slides. So this is basically survival analysis, which again, a basic test to be done is log rank test. So log rank test can be done in any case of survival analysis, and we will be plotting a Kaplan-Meier plot. So again, this is one of the studies where we have compared different surgical techniques for pediatric glaucoma. And as you can see, this one, the 0.8 is basically, the x-axis is basically the survival rate, and the y-axis is the time period. So survival analysis, basically the time until an event occurs. So the event need not be a death all the time. It means the event till the treatment fails. So there is 80% likely that this particular technique, that is Ahmad glaucoma valve, will be effective for more than 6 years. Whereas when you compare with the CPC, it is only 30% likely that this treatment will be effective for 2 years. Next slide. So this is the last slide. So this basic statistic analysis to see the sensitivity and specificity. So you will be plotting the sensitivity on the y-axis, which in other words is the true positive rate, and the false positive rate on the x-axis, which is basically 1 minus specificity. So any value which is closer to 1 is kind of a perfect classifier. So ROC curve is basically you want to know which parameter is better for classification or diagnosing a particular disease, or whether you have a specific cutoff. Like for example, if you say keratoconus, if you check all the parameters in the pentacam, which parameter is the best parameter to pick up early keratoconus? So if you want something like that, among a lot of parameters, if you want to choose one, then you can actually apply this ROC curve, and the parameter which is showing more sensitivity and specificity will be the perfect classifier. So you will be having an area under curve. If it is almost close to 1 means it is a perfect classifier, or if it is less than 0.7, it is not a very good classifier. With this, I think I will conclude my talk. Thank you, ma'am. Thank you, yourself.
Thank you.
Thank you so much, sir. Vanity ma'am, if you're there, could you please give us some concluding remarks on the webinar before you leave? I understand, ma'am, you have to leave for another webinar.
Yes, ma'am.
I think statistics has always been a very difficult part for us medical people. Otherwise, we would not have done medicine. We would have done something different. Yeah? But I think the most important part is learning to apply statistics to our clinical interpretations. So what we basically have is we are operating, we are doing some interventions on our patients, and we are getting a clinical outcome in terms of visual acuity, or in terms of better control of IOP, or whatever is the outcome which we have, which we desire. And we are trying to give a statistical significance to that particular clinical interpretation. So you have a set of tests which you are applying. And I think it is better understood as and when you're doing your study, and as and when you have clinical examples. That's when it is easily understood. Otherwise, it becomes a very dry subject, and it becomes a little too difficult to comprehend as well. And I will still say I am still learning statistics. And, depending upon the different type of studies which we do, when my residents again go in for a biostats analysis, I still learn something new. I still pick up something new. And I think you do not get very perplexed, or you do not get, frustrated, because you will always, statistics is something is very volatile. You'll probably have to keep going back and revising it. And that's natural. So you don't need to get worried about it. And you probably will need an expert to probably explain it to you every time and tell you the way you have interpreted is correct or not correct. So it comes with practice. So you do not need to get worried about it. And I think we as clinicians can never be experts of these. We probably know what to apply when. But when you're reviewing, when you're performing as reviewers, you should know whether a particular test applied is correct or not, or you should be able to at least identify that the statistics applied to this particular paper is not adequate. The same applies is what we learn when we are doing our post-graduations, or when we are doing our researches, is basically to learn what is the right way of going about a research, not only just conducting the research, but also looking at the statistical interpretations. It comes with practice, and it will just happen to everybody. So there's no need to get worried about it. And I still feel I'm still learning. I'm learning lots still, and it's a very interesting field.
Thank you. Thank you so much, ma'am. Your words are actually gospel for the young audience that is over here. And since you used the word post-graduation and residence in your last monologue, I just add one last question, if you just have 2 minutes for us. There are a lot of young residents and young fellows who are watching this webinar who always have this question that I want to publish, I want to go beyond my thesis, I want to publish a paper. Sometimes they get stuck at their first publication, sometimes they get stuck at their first rejection. So to hear it from the horse's mouth, what are some things that one should always look out for before sending in their publication? You can include statistics or outside it as well. And as a journal, what are some things that you look for in a paper?
See, you apply statistics when you're looking at original articles. You apply statistics when you're doing meta-analysis here. But when you're a beginner, you're probably doing something very simple as a case reporting. And now I think IGO has a good way of giving you IGO videos. It gives you photo essays. It gives you ophthalmic images, which is a sort of a way to encourage you to publish. So I think the first bottom line is, please go and read journals. So that's very important, to go back and read journals to understand how particularly things are written. It's something like reading a story. It's something like making a movie. It's something like making a video. You should learn to understand that this is a particular format by which you have to do it. And again, remember, you would always go to a shop where things are displayed beautifully, so it's the power of suggestion. So somebody is writing badly, that's going to put off your reviewers point blank. So I do not mean that you have to be a fantastic literarian, that you should have a good command of your language, but just simple language, keeping your grammatics correct. And now I think you have several online softwares that's going to help you on getting your grammatics right, getting your English editing right. So it's not very difficult as it used to be in earlier times. So these are very important things when you're starting to write. The bottom line is, please read more. Once you read more, with a matter of time, you yourself will know what is the format of writing, and then mention very simple things like putting your references in proper styles. These are very important. Then you move on to the second step of applying statistics. So start publishing from the basic things. I think if your YOSI, IGO live buyer goes through, then we can plan perhaps every 6 to 8 weeks. We can look at how to do a case report, how to do a photo essay, how to do an original article. So these are the common things, and these are where the youngsters usually get stuck. And I'll be very, very happy to really help you out. And it's a matter of pride for me to see more and more of young India come forward and publish international quality articles. I mean, that's my dream, and that's what I want to see. The veterans can always do and can publish anywhere, but I think I would have got my message clear if I get the young minds to come and give me international standard articles. I'm always there. Please reach out, and I hope with Nupur we'll work out something more fruitful with a fantastic team which is sitting here with all of you. I'll make myself free to be with you every 6 to 8 weeks, and I will also try to get on panel people. For example, if you have glaucoma studies, and like Mithun said, if you want people, you want examples, you want something in cornea studies, you want in retina studies, I can help my colleague. I can request my colleagues to also be with you, so that they would also help to contribute. Be happy to be with you all.
Thank you, ma'am. You have really encouraged us, and I think the IGO YOSI live wire, the suggestion is excellent, and let's plan on it. It is,
Sure,
I think,
sure.
fantastic. Yes, ma'am. We'll definitely work that out. Thank you so much, ma'am, for sparing your time with us and being with us throughout the webinar, giving your nuggets of those small words of encouragement, and also chipping in your inputs. Thank you so much, ma'am. And I understand you have to, I think, go for another meeting. So before you log out, ma'am, we have a mandatory YOSI photograph, a screenshot, which we'll take with you, and then you can probably carry on. So, ma'am, we do this yo sign when we take yes. Dr. Prasanna, can you switch on your camera? Rohit, if you're there, and the other audience as well. I'm sure there's a lot of audience who will be watching this on the YOTube. So, Anujit, you're taking the screenshot?
Yes, ma'am. I've taken the screenshot. Thank you so much.
Thank you, Anujit, ma'am. Thank you. Thank you so much.
Thank
you, ma'am. It was a pleasure having you. Thank you.
Thank you.
Bye, ma'am. Yeah, so I think we'll continue with Zain. Zain, you have any inputs and about the statistical test that
so thank you. So basically, I think the 3 presentations were very comprehensive. And just to conclude, I would like to say that biostatistics is very vast. Okay, it's really vast. There's a lot. But the good news is that we don't need to know all of it. We just need to know 5% of it. And See, when I started in my residency, honestly, I did not know anything about biostats and publications. I was very raw. It's only when I went into fellowship, I actually, started considering publication, and I have not published much. Okay, so I am not like Prasanna with 140, 150 publications. I have, I have 7, 8, publications which I have studied myself, done the biostatistics myself, because whenever I would work with a biostatistician, I always realized that he would never understand what I wanted. So why I started learning biostatistics is because I felt that if I want to put my thoughts over there, I need to understand the tests also. And as far as the tests are concerned, I think those 2 slides by Dr. Mithun summarized everything very, very well. I think that is what you need to know. As a young ophthalmologist, you need to know the names of those tests. You need to understand what those tests do, parametric, non-parametric, and those things. And once you understand that, you can easily publish, 2, 3 simple comparative kind of studies. Uh, and then once you understand that, I think you should go into regression analysis. So regression analysis is something which is more complicated, and something which obviously he couldn't cover in such a short period of time, but it needs some time to understand. But then once you get these basics, you can go on and do that. So, just knowing those tests, learning yourself, and as Dr. Rohit and Prasanna said, understanding p-value and sample size, you can easily do yourself. I have won 3, 4 awards for some of the articles, and I was very sound about the tests. If anyone would cross question me, why have you done this, why have you done that, I was very confident that I know that this test is for this and this is done like this, so no one can cross question me on that. And that is all you need to know, that 5%. So good job, very good webinar, and good topics.
So this is just thank you, Dr. Zain. This is just first in the series of biostatistics. We, hope to have this more over a period of time. Because biostatistics, we have a long 3, 4 hour webinar, probably it would become a little dry. So we've decided to break it down into parts. And, obviously this will be there on the BioTube, so people can keep going back and watching this. Also a word of thanks to Dr. Rohit for designing the topics. So Rohit is the YOSI Journal Club statistical expert. He's the expert. So thank you, Rohit, for suggesting the wonderful topics and giving the outline to the program. Thank you. Just Dr. Mithun, Dr. Zain, Dr. Rohit, any recommendation for the bios who are watching on BioTube? Any specific book? Rohit mentioned a couple of articles, I think IGO articles, which are good to read. Zain, you said you've learned statistics on your own. So where did you learn it from? If you can just share it with the...
Yeah, please enroll for the Sengupta Research Academy Fellowship Program. It's very good. It will teach you all the basics. That is where I learned. And basically, I started using a software called MedCalc for biostatistics. The advantage of that is all the tests are given in language which you can understand. It's not coded language. So, if you want to use a student's t-test, or if you want to use Kruskal-Wallis test or something, you can click on the help button. It will tell you what the test is for and what it is doing. So it's a good guide along with. So I started using that software after I enrolled in Sengupta Research Academy. So Sengupta Academy is very good. I think that's where I learned from.
Even I agree with Zain. Actually, Sengupta Academy is a very good platform, especially for ophthalmologists. Like we'll get to know our data, our parameters, our kind of environment, so that we can apply it very nicely. Otherwise, if you ask me, there is a YouTube channel known as Data Tab, DATATAB, Data Tab. It's by some German woman, but it has all the lectures in short lectures, around 5 to 10 minutes, about all the tests, and even they have an online statistical calculator and web page. So Data Tab, if you can go to YouTube and subscribe, and if you see the videos, they say it in a very simple way, so that it's very easy to understand. Most of the time, we don't bother to learn this because it's very complicated. But they make it very simple somehow. But yeah, the first choice is definitely Sengupta's research.
I wanted to add, American Journal of Ophthalmology has a series on statistics and epidemiology articles. I think they are free to download. We can just recheck, but AGO, we have an access through the AIS membership, if I'm not wrong. that series of articles will simplify biostatistics for us. No doubt, I have not actually gone through Dr. Sunny Sen Gupta's academy. I'm sure it is good. The LVP fellows mostly learn in their own biostatistics class, which is conducted in LVP. But the AGO series is helpful, and also the IGO, our own Indian journal, has got a series on biostatistics when I think so Barun Naik sir was the editor. So during those years also, those articles are very simple to understand.
In that time, there was an article on how to choose the right statistical test by Varun Naik. There was an editorial saying.
Yeah.
Thank you all once again. With this, there are no any comments from you, Anuji. Anything you want to add?
No, ma'am, I think we've covered a lot in a very.
Yeah, I think this was a very, very nice webinar. It was very, very nice. The presentations were excellent. The talks were excellent. So with this, we'll call it a wrap. And I would like to, end with a vote of thanks. I would like, at the outset, I would like to thank our chief guests and panelists, Bhagati ma'am, for sparing her valuable time with us, being with us, encouraging us. Also, under the pipeline, we may come up with something as suggested by her with the IGO YOSI live bio. So if you're watching this webinar and you have any inputs, please do feel to write to us at the you can connect with any of us, Anujit, me, Rohit, any of us, and we can just take this forward. And thank you to all the speakers, Dr. Rohit, Dr. Mithun, Dr. Zain, our panelists, Dr. Prasanna, for a wonderful presentations, wonderful discussion. Thank you, Dr. Anujit, for being the fantastic moderator as always. He's the backbone of Journal Club. He's been relentlessly working for the Journal Club sessions. Thank you, Anujit, always. I would also like to thank the YOSI Governing Council President Dr. Sonal Kalia, who actually started the Journal Club series, and she gave us the opportunity. Our Secretary Karan Bhatia, he couldn't join today, but he has been working with me throughout designing this whole session and helping coordinate everything, and to the entire Governing Council. And to all the audience who were with us tonight and who are watching this on YouTube, thank you all so much. And with this,
Before we end, I would like to take the opportunity to thank you, because this entire statistical class and all the Journal Club episodes have been orchestrated, and right from the skeleton structure have been done by you. I had a very little role to play in this session.
That's not true. It's just been too.
So thank you, ma'am, so much. And I'm sure this will be the start of something big as well.
Yes, definitely. Thank you. So we can, I think we've already taken the screenshot. I'll just end